Hey, hi, Rajan this side. Welcome to the channel. So we have started a 100-question DSA series that will help you to crack any coding interview. And in this series, we will discuss each and every data structure algorithm, and we will cover each and every possible question that could probably be asked in an interview, right? So we have started with array first, and in array we will discuss the fifth problem today. The problem name is called sort an array of zeros, ones, and twos. So the problem statement is that you will be given an array that consists of zeros, ones, and twos only, and the objective is to sort the array. Sorting means so keeping all the zeros first, then all ones, and then all twos, right? But the tricky part is that you have to sort them in place and in single traversal. So that's the tricky part. So now to solve this problem, we will start with the brute force first as usual. So whenever a question asked in an interview, always start with the brute force approach and then try to optimize it, right? So the brute force approach would be to sort this array by using any conventional sorting algorithm. Let's say you are using merge sort, right? So the complexity would be order of n log n. But this is not optimized. We can do much better than this one. So the thing is, if you observed in this question carefully, the numbers could be either zeros, ones, and twos, right? Which is just three. So as an optimization of it, what we can do, so this is the first brute force approach. Now in the second brute force approach, what we can do, we can use three variable, uh, three variables to store the count of zeros. The second variable can be used to store the count of ones, and the third variable can be used to store the count of two. Let's say I call it 0, 1, and 2, right? So 0, so in this test case 0 would be 1, 2, 3, and 4. So there are 4 zeros, and if you count the number of ones, it is 5, and if you count the number of twos, it is 6, right? So these three variable would stores the frequency of zeros, ones, and two respectively. And we know that after sorting, your array should look like all zeros first, followed by all ones, and then followed by all twos, right? And we know how many number of zeros present, ones present, and two present. So what we can do, we can use any for loop or while loop, and we can keep four zeros. So in this example, we can keep four zeros first, then five ones, right? And then six twos, two, right? So in this approach, your complexity is order of 2 into n, right? So so precisely it's 2 into n, but in in big O notation it's called order of n. But I would like to highlight this part because in the problem statement we have to do it in one traversal, right? But here we are using two traversal. First traversal would be used to store the frequency of zeros, ones, and two, and the second traversal would be used to keep all the zeros, then all the ones, and then all twos, right? So here the complexity is order of 2 into n. And one more thing, in this second approach we are not doing it in place. In place means you kind of modify or you do the operation in the same array itself. You are not, so you shouldn't use any extra variable for that. But in this approach we are not following the objective of the problem, because we have to do this sorting in place and in one traversal, right? So in order to solve this problem in place and one traversal, we will use a very famous algorithm called Dutch national flag algorithm. Let's see how it works. As discussed before, in order to sort this array in place and in one traversal, we will be using Dutch national flag algorithm. This algorithm is pretty simple. It uses three variables: low, mid, and high. So this is low, this is mid, and this is high, right? So these are the pointers. Now initially low would be 0, mid would be 0, and high will be n minus 1, right? So it says if your current number at the mid pointer is 0, what you do, you swap with low and increment both low and mid. We know that all the zeros should comes in the beginning, right? So that is why if the number encountered at mid pointer is 0, swap with the low, because I want to keep it at the beginning, right? So swap these two and then do low plus plus and then mid plus plus. We'll understand through test case, then it will be clear for you. Now the second says if the value at the mid pointer is 1, don't do anything, because we know that all the 1 should be present in between, right? In between 0's and 2. So don't do anything, just move forward. So just do mid plus plus. Don't do anything. The third case, if the number at index mid is 2, what you do, you swap with the high pointer and move high one step backward. So we know that all the 2's should go at the end, right? That is why what I'm doing here, I'm swapping 2 with the high one, right? Swap these two and do high minus minus. Don't do mid plus plus. I'll explain you why. But before that, we will try to understand this algorithm in a test case. So let's take a test case 1 0 1 1 2 0 0. So initially both low and mid would be pointing to the first index. So this is my low and this is my mid. Both are pointing to the first index, and high is pointing to the last index, right? So since the value at index mid, ARR of mid is equals to 1, what you do mid plus plus, right? So once you do mid plus plus, your mid would be pointing to here, right? So let me just simply refactor. So now your mid is pointing to this index, right? Now again the number is 0. Now once you encountered 0, what you do, you have to swap with low and increment both low and mid, right? So now we have to swap these two numbers. So once you do swap, your array would be 0 1. After doing swapping, then rest everything as it is. And here is my high. Now if you observe, after swapping, what we have to do, we have to do both low plus plus and mid plus plus, right? So now low would be pointing to here and mid would be pointing to the here, right? Now the number at index mid is 1. So once you encountered 1, don't do anything, just do mid plus plus. So go to the next index. Now here also the number is 1. So what you do, you just increment mid. So mid would be pointing to here. So let me quickly change it. So now your mid would be pointing to here, right? Here. Now the number at index mid is 2. So once you encounter 2, what you do, you swap with high and move high one step backward, right? So now we have to swap these two and we have to move high one step backward. So once you do that, your array would be 0 1 1 1. Now once you do swap operation, this is 0, this is 0, this is 2. Here is low, my low. Now here is my mid. So if you observe, mid is not changed, because when you encounter 2, you just do high minus minus. We are not touching mid at all. So now your high would be pointing to the second last, right? This is my high. Again, this is my mid. See, if you observe here, like you may think that why we are not doing mid plus plus here in the third step. The reason is, once you encounter 2 here, you swap with the high, right? We have swapped with high, but see, after swapping you encountered 0, right? So if you do mid plus plus, just think about it. This array is sorted, right? 0 1 1 1. So before mid your array would look like few numbers of zeros and few numbers of 1, right? But if you do mid plus plus and given you have a 0 here, then it is not sorted. It would look like 0 1 1 1 1 1 and then 0, and then mid would be pointing to the next index if you do mid plus plus. That is the reason why we are not doing mid plus plus here. Instead we are waiting for the next step. So in the next step, so in the first step, what we have done just high minus minus. Now we come back again. Now here the number is 0. Now we will do the first step. Now we will swap mid with low, and we will do low plus plus and mid plus plus. So here now what we will do, we will swap these two. So after swapping, your array would be 0 0 1 1 1 0 and 2. Now we will do low plus plus. So this is my low, and once you do mid plus plus, this is my mid, right? And this is my mid, and this is even my high also here we both have mid and high, right? So now the number at index mid is 0. What we will do, we will simply swap these two, low and mid. So after swapping, now your array would be 0 0 0 1 1 1 and 2. And see, this is sorted. And once you do mid plus plus and low plus plus, so low would be pointing to this index and mid would be pointing to the last index. And so here is my mid, and but high is unchanged, right? High is here. But see, now we will break from this while loop. So this is actually the pseudocode. We will be doing this operation only when, like, only till your mid is less than or equals to high. But once your mid is more than high, just break it there. So see, after doing this operation, your array is sorted 0 0 0 1 1 1 and 2, right? So I hope you understand this part. The only question, if you have in mind that why we are not doing mid plus plus, I have already explained that after doing a swap operation with the high, it might be possible that you found 0 here, right? So see, in this example, after swapping 2 and 0, we found 0. So if you do mid plus plus, we won't be handling the first case, like, right? That is why just wait in the next step, and once you come again back to this index, we will swap 0 with the low, and we will just keep on doing this process. So after doing this, like, sort of following this algorithm in this example, in this test case, we have seen that the array becomes sorted. So yeah, I hope you understand the algorithm. The algorithm is pretty simple, and even this is the code of this algorithm. Low is 0, mid is 0, high is n minus 1. And we will do this while mid is less than or equals to high. If the number is 0, swap low plus plus mid plus plus. If the number is 1, just do mid plus plus. Otherwise, swap mid and high and do high minus minus. So yeah, but it's better to look at the like complete code. So yeah, let's look at the code now. And if you find any difficulty anywhere, please try to comment. I'll explain in the comment if you have any query, right? We look at the code. We are given this array that consists of only 0's, 1's and 2. Now in order to sort this array in place and in single traversal, we will be using Dutch national flag algorithm. I have explained in the explanation part how this algorithm works, so please check out. So in this algorithm, we will be having three variables: low, mid and high. Low and mid start with 0, high start with n minus 1. So, and we will traverse through this array using mid variable. So while mid is less than or equals to high, we will check what is my current number. So current number is ARR of mid. If the current number is 0, swap with low. So swap ARR of mid comma ARR of low. Now do swap operation and then increment both low plus plus and do mid plus plus. I mean, increment both low and mid pointer. If the current number is 1, don't do any swap operation, just move forward. Now if my current number is 2, so if x is not 0, not 1, so it definitely 2. If it's 2, swap with high pointer, so swap ARR of mid comma ARR of high. But in this case, just do high minus minus. I mean, just move high one step backward. Don't do mid plus plus, because it might be possible that your current number after doing swap operation is 0. So we have to handle the first case, right? So in the next step, we would be handling that part. So that's why don't do mid plus plus, wait for one extra step. And just return here, because we would be doing this sorting in place. So here we are kind of modifying the array, so we are doing all the operation in the same array. We are not using any extra variable for, or any extra space for sorting, right? So we are doing in place, and here we are just having a single traversal. So yeah, our objective is accomplished. So yeah, this is all about this problem. If you find the video helpful, please like, share and subscribe to my channel. Thanks for watching.